Is it going?
I think so. Hi. They like it when we start that way.
You think we would know how to do this by now?
Figured out.
Miss Harkin.
That's all right.
It's the Henning and Harkin show.
Yay!
Yay! And it's our last one of the year.
Oh, don't cry, because I know you'll miss us next year a lot.
So we're going to show you how to draw a model of every atom on the periodic table.
What?
Any of them.
Oh.
And this format was designed by a scientist named
Bohr.
Mr. Bohr.
Mr. Bohr. I think you might have learned about him.
And he's not boring either.
Oh, so exciting.
Yes.
No, he did not have a boring life.
So, getting out your notebook, of course.
Oh, you got to write this stuff down. There's steps you will need to have. So you need to write this down.
We're actually going to use our PowerPoint here to do some drawing also. So we're going to not have it on the presentation mode. So you can, you'll
be fine.
Yep. All right, so here we go. Here's step one. Here's step one. There we go. So we're going to use our periodic table.
Ooh,
and we're going to find aluminum. We're going to start with aluminum. And we're going to make a model of what the aluminum atom looks like.
Right. So first you have to remember back a long time ago, and we talked about the protons, neutrons, and electrons that are in aluminum.
Yep.
And we already have used this to determine how many protons, neutrons, and electrons we have.
Yep. So here's our atomic number, which is going to equal our number of protons and our number of electrons. So we're just going to write 1313 in there. And the tricky part was the neutrons here.
And you just have to subtract.
We're going to use our mass because that's the protons plus the neutrons added together.
Because they live in the nucleus, remember, in that little house.
So the 13 plus what will give us approximately 27. We're going to round that up. So we would subtract, just like you said, which would give us 14. 14 neutrons in there. Ooh. So now we're going to draw those in our model.
Yes.
Step 2.
Step 2. Okay, so you're going to start by drawing a circle that's going to represent your nucleus. And you're going to put inside your nucleus, you're just going to write, we're not actually going to draw out each little dot, but you're going to write the number of protons and the number of neutrons you have in there. And you need to make sure you label which one's protons and which one's neutrons, because otherwise we won't know which one is which.
So we're going to put P equals 13 and N equals 14. Almost said 14, right?
Perfect.
That's our nucleus. That's step 2 done.
Step 2. Whew.
All right.
Easy peasy.
I'm going to copy that because I'm going to need that for the next. So Control copy. Next step 3.
So now the tricky part is you have to figure out where those electrons live. So we've talked about it a little bit before, but electrons live in energy levels around the nucleus. So they're not just in one big circle, there's multiple levels.
Yep.
And you're like, how are we going to figure out how many levels there are?
I know, it's kind of confusing.
Yeah, a little bit. Yeah. So you got to use this guy.
Oh, yeah, the periodic table.
It tells you everything.
It does. It tells you everything.
Okay, so you're going to look on here, and you're going to find aluminum. Boop, right there. And aluminum is in the 3rd row.
3rd row. Count them. 1, 2, 3.
Or period
is
the name they give those. But it's in the 3rd one. So 3 energy levels.
So we're going to draw 3 circles around, which we have to not use a fill button. No fill. And we're going to do that 3 times.
3 times. Now, you don't want to count that first, your nucleus there, as an energy level. That's your nucleus. Don't count that.
So I'm going to draw 3 of these. Look at me cheat here. Get them just a little bit bigger on there. Move that second one just a little bigger. And you're going to draw them a lot easier than what.
So you should be drawing this in your notebook. So you have the idea. Okay, so 3 circles on the outside to represent the 3 energy levels that aluminum has.
There you go. That's step 3.
Step 3.
Yep, looks like that. Now I'm going to select all that. Got to get all those because now we do the next step. And Control copy that. And we go on to step 4.
Step 4. Okay, so each energy level can hold a different amount of electrons. So that at first look confusing, but once you figure out the pattern, it's not.
Yep.
So the first energy level can hold 2. The second energy level can hold 8.
Yep.
And then you can use an equation, 2 times n squared, where n is the number that you find on the side over here, to tell you how many electrons can go in each energy level after that.
Yep. So if we paste our little drawing here, hold on for a second, will you? Yep. And what we want to do is we start writing with our words. We're going to type in here 2 electrons, or 2e, on this first energy level. So if I had the ability, I would be doing that. I would write 2e here because there's 2 electrons on that one. Then I'd write 8 electrons out here. And then on this last outside energy level, we're going to use dots. And since we have 10 on those first 2 energy levels and we have 13 altogether, we're going to put 3 dots on this outside. Okay? And then the last thing we'll talk about is our valence electrons. And I think we'll just say that for another video. How's that sound?
That sounds good.
We'll just do a short little video on Lewis dot diagrams. Since our bell rang.
Okay.
Thanks.
Bye.